All right, let's talk about something a little weird in the Python programming language. We're going to dive into the strange and paradoxical world of constants. Now, if you've ever coded before, you'd think a constant is something that, is constant. It never changes. But in Python, yeah, that's a bit more complicated than that.
So let's just cut right to it with the one question that gets to the heart of the whole thing. If you set pi to 3.14159 in your Python script, is it really a constant? Can you be 100% sure it's going to stay that way? The answer, you might find, is a little surprising, and it tells you pretty much everything you need to know about Python's philosophy. Okay, so before we unpack Python's unique way of doing things, we need to understand why constants are even a thing to begin with. And it all comes down to solving a classic headache in programming called the magic number problem. So what in the world is a magic number? Well, it's any number that just kind of appears in your code out of thin air with zero explanation. It might make total sense to you at 2 a.m. when you're writing it, but when someone else looks at it, or even when you look at it 6 months later, it's a total mystery. It makes code a real pain to read and an absolute nightmare to update. Just look at this line of code. Total price equals item price times 1.07. What is 1.07? Your brain immediately starts guessing. Is it a sales tax, a service fee, a currency conversion rate? Who knows? But if that number had a name, like sales tax rate, you'd know instantly. That's the problem constants are built to solve. And this is where we get to the core paradox. See, most other programming languages solve this magic number problem with very strict, very clear rules. Python, on the other hand, well, it doesn't. Its whole approach is based on something else entirely. And this table just lays it all out perfectly. On one side, you've got languages like C++ or Java. They use special keywords like const or final. The compiler, the program that builds your code, will actually stop you and throw an error if you try to change that value. It's a hard rule. But then you look at Python, and it relies entirely on convention, basically a gentleman's agreement among developers. So let me just repeat that because this is the key takeaway. There is absolutely nothing in the Python language itself that will physically stop you from changing the value of a so-called constant. For programmers coming from other languages, this can be a real shock. The protection isn't in the language's rules, it's in the developer culture. So if the language isn't going to enforce it, how does this system not just completely fall apart? Well, it works because of a very powerful, universally respected rule. You might call it an unwritten rule, but actually, it's written down pretty clearly for everyone to follow. And this rule comes straight from the top, from what's basically the holy text of Python style, PEP 8. This is the official document that lays out all the conventions for writing clean, readable Python. And inside, it gives us a very clear guideline for how to tell the world, hey, this thing is a constant. The convention itself is super simple but incredibly effective. It's called all caps snake case. Here's how it works. First, all the letters are uppercase. This makes the variable name visually scream at you from the page. Second, if you've got multiple words, you separate them with an underscore. The result is a name like max size or database URL. And that's the secret sauce. That's the entire magic trick. When a Python developer sees a variable name written in all caps, their brain instantly knows, do not touch this, do not reassign this, treat it as read-only. It's a powerful social contract that keeps our codebases clean and predictable. Okay, so theory is great, but what does this actually look like when you're writing code? Let's take a look at how you'd properly organize and use these conventional constants in a real project. It really boils down to 3 key best practices. First, you always define your constants at the very top of your file, what we call module-level scope, meaning it's not tucked away inside a function or a class. Second, for any project bigger than a tiny script, you should stick them all in their own dedicated file, maybe called constants.py or config.py. And third, the golden rule: respect the caps. Never, ever reassign them. And creating a dedicated constants.py file like this is just so clean. It's a game changer for keeping things organized. You can centralize everything from math values like pi to important application settings like max_connections or app_name. It becomes the single source of truth for your entire project. Now look at the payoff. When you go to use them in your main code, it's beautiful.
You just import the constants you need, and the code practically reads like plain English. That line return pi times radius squared is instantly understandable. No more guessing what some long decimal number means. This clarity is exactly why we follow the convention.
So this whole system is built on trust, right? On this shared understanding. Which leads to the obvious question. What actually happens if some rogue programmer just decides to ignore the all caps warning and changes the value anyway?
And here it is, the smoking gun. The code imports pi and prints its value. Looks normal. Then, boom. The next line just says pi equals 4.0. And does Python throw an error? Does it even give a warning? Nope, not a peep. The output confirms it. The constant has been successfully changed. This is the ultimate proof that it's all just a convention. So, why? Why on earth would a programming language be designed this way? Well, this isn't an accident or some feature they forgot to add. It is a very deliberate choice that gets right to the core philosophy of Python and its community.
It all comes down to this one famous guiding principle you'll hear all the time in the Python community. We are all consenting adults here. And that single phrase captures the entire idea that Python programmers are trusted to be responsible for their own actions. So, what does that philosophy really mean in practice? It means Python trusts you, the developer, to do the right thing. It chooses to keep the language simple and readable rather than building in a bunch of strict, rigid rules. It just assumes that if you see max connections written in all caps, you're smart enough to know what it means and you won't change it on a whim. The responsibility for writing clean, stable code lies with the programmer, not with the language itself. And that brings us to the final big question. This deep-seated trust in the programmer, is it a feature that makes Python so flexible and simple to use, or is it actually a bug, a potential landmine just waiting to cause subtle, hard-to-find errors, especially in large teams? There's no single right answer, but understanding that debate is the key to understanding what makes Python, well, Python.